Hi, I'm Nate Spack, and I'll be presenting on Chapter 3, Segment 2 of the Psychology textbook today. So neurons use electrical signals to summarize information from many synapses. In neurons, the voltage difference across the membrane is constantly changing, with potassium ions crossing the membrane readily, whereas sodium ions are crossing through gated ion channels. Voltage returns to resting potential every millisecond through pushing sodium ions out, and the more synapses that are active, the more the neuron's voltage will change. Synaptic input determines whether a neuron will produce an action potential. So an action potential is also known as a nerve impulse and is known as an electrical message of a neuron that travels through the axon to the axon terminals. Now, depolarization is the reduction of the polarization of a neuron, making it more likely to fire, and usually this is accomplished by what I call excitatory synapses. And the threshold is the point to which a neuron must be depolarized in order to trigger an action potential. Now, hyperpolarization is the increasing of the polarity of a neuron, making it less likely to fire, and this is usually accomplished by inhibitory synapses. Now, the axon is the part of the neuron that produces action potentials, and the axon hillock is the widest part of the axon, right where it originates from the cell body, where voltage-gated sodium channels are found. Once begun, action potentials travel down the axon. So action potentials travel between 1 and 250 miles per hour. The all or none property states that nerves produce action potentials that are always the same size regardless of the stimulus. And the refractory phase is right after a neuron fires, the 1 millisecond delay before it can fire again. And this is because the voltage-gated sodium channels close for a short time after they open. And finally, action potentials always travel in the same direction no matter what. Now, myelin speeds up action potentials. So the speed of an action potential depends on two things, axon thickness and myelination. The thicker the axon, the faster the action potential. And if the neuron is myelinated, if it has a myelin sheath, then the nerve impulses will travel faster as well. So myelin is just a fatty insulation around an axon, which speeds up the conduction of action potentials. The nodes of Ranvier are breaks in the myelin sheath where saltatory conduction takes place. This is just the action potential jumping from one node of Ranvier to the next through the myelin sheath, and this is the faster form of conduction which myelin facilitates. And there's very little myelin in our brains at birth, so fat is extremely important in the diet so our brains can myelinate and our brains can develop. Multiple sclerosis results from the immune system attacking this myelin, causing sensory and motor problems. Now, what happens when the action potential reaches the end of the axon? Neurons, first off, they utilize both electrical and chemical signaling, chemical messaging. And Otto Loewy, before it was discovered that that neurons use both chemical and electrical messaging, performed an experiment to determine whether neurons used chemical or electrical signaling. And he used frog hearts in his experiment, and he concluded that they utilize chemical signals and that acetylcholine is a major neurotransmitter involved. And at the end of the axon tip is what releases a chemical signal to pass information to the next neuron. Drugs and hormones affect brain signals. So, due to the fact that neurons use chemical signals, drugs and hormones are able to have an impact on brain signals. And First off, an agonist is a drug that activates a receptor just as any other neurotransmitter would. For example, heroin is an agonist, and an antagonist is a drug that interferes with neurological signaling by preventing a neurotransmitter from binding to its receptor. And hormones are chemicals that are released into the bloodstream from one part of the body that will affect another part of the body. So endocrine glands are glands that secrete hormones, and almost all hormones have impacts on the brain. Now, the pituitary gland is an endocrine gland in the brain that releases hormones which impact every other endocrine gland, and that sometimes is known as the master gland because it has so much power, if you will. And these hormones can a lot of times impact behavior as well. For example, testosterone in males makes them more aggressive or more likely to try and attract a mate. That's my presentation.